Coming up, we have Cameron Mehlman, who is the CEO of SkyShadow Corporation. And we're moving in a completely different direction now. We're enabling the future of autonomous drone capabilities. Cameron, tell us all about SkyShadow Corp.
Great. Thank you so much. My name is Cameron Mehlman. I am the CEO and co-founder of SkyShadow, where we like to believe we're enabling the future of autonomous drone capabilities by providing onboard diagnostic and optimization solutions. So I like to start the talk just by introducing the team. There's myself, which if anyone could hear my kind of background for 2 minutes ago, I'm a PhD student here at Cornell University in the Aerospace Adversary Lab. I focus on edge-based autonomous systems for drones and satellites. I'm also a year-round researcher at Sandia National Labs, where I focus on developing tools for drone swarm capabilities. I'll be joining Anduril over the summer for a couple months to help integrate new AI tools into their research development process. Next, we have my mentor and CTO, Dr. Gregory Falco, who's an assistant professor here at Cornell in the Aerospace Adversary Lab. He's also a three-time founder, and I think that's wrong. There's actually 3 successful exits, the most recent being his startup Foci, which was sold to Pasteur Labs at the end of last year. And he also received his PhD in computer science from MIT. Our chief strategy officer is Dr. James Rogers, who is a director of the Brooks Tech Policy School. And he is really a leader in the drone warfare space, essentially wrote the book on drone usage in modern warfare, has been an amazing asset for giving us a more policy and higher level look at what the drone industry needs to grow. And our VP of Defense Solutions, John Miller, who is an active duty major in the United States Air Force, currently getting his PhD here at Cornell, but when he returns, will be working in close collaboration with the Air Force's new drone division. So what we do here at SkyShadow is we offer self-healing diagnostic software. And I think the best way to explain why we were motivated to design this is a scenario that pretty much any drone operators probably run into, which is you turn the machine on, all lights are green, and it doesn't fly. So for an experienced drone operator, this means you could be spending anywhere between the next 10 minutes to 4 hours trying to understand what's wrong. For an unexperienced drone operator, your everyday user, you might be able to buy a new drone and have it flying in less time than it takes to throw out your current one. So what we're seeing in the drone industry is that issues that really reside in a lack of understanding between the user and the hardware are starting to percolate and create a lot of problems for larger scale drone implementation. And there's a lot of uses for drones in industries such as emergency relief, first response, and especially defense, which SkyShadow is kind of targeted as our primary market. And the reason we've done this outside of our close relationship to the defense field is that there is going to be a massive growth in the investment in the drone industry. So this is a diagram that just quickly shows we're expecting to see 2 times growth in drone defense investment in the next 5 years. And as somebody who works in the drone defense field, what we were able to recognize is a huge strategic component to this is being able to scale the amount of drones per user. A lot of the capabilities that drones offered are great as a single machine, but as a team can really grow immensely for applications such as reconnaissance, search and rescue, package delivery, even for civilian applications. But the problem is you can't have a single operator manage 20 plus drones if there's not a quick and easy way to fix them when they break, which happens often. There's simply not 400 hours in the day for each person. So what we realized is the scenario that I painted 2 slides ago is going to become a massive bottleneck in the drone industry if there's no provided solutions. So at SkyShadow, we're trying to tackle this really through 3 pillars. We're trying to reduce the amount of time it takes to troubleshoot. We're trying to increase the accuracy and fidelity of the diagnostics that the user receives. And then the combined effect is that a single user can manage a large number of drones for whatever their application or mission may be. So the next question that I think I normally get when we present this is, well, why hasn't anybody done it? And the answer to that can really be answered in one sentence or or 3 words, which is drones are hard. This is a pretty basic block diagram, but I think it well enough explains how many moving parts and interactions there are inside a drone. So in order to create these solutions, you really need a team of engineers that very intimately understand all the different actions or interactions going on in these systems and how we can build the best system to diagnose and fix these issues. So because of our expert team that we were really able to build here at SkyShadow, we were able to put together a hardware device that you can put on a drone, and what it does is it takes real-time data, raw data from the drone during flight, is able to use machine learning and fault tree diagnostic tools to understand what's going on, how we can fix it, and then ideally mediate the drone with minimal human interaction. So what we did was we built this out and we put it on a drone and we disabled a motor. And what you're going to see in the next slide is a demo where the drone is able to detect that a motor is shut off. It can determine which motor is shut off, and then it can fix the configuration parameters of the drone without any human intervention, enabling it to fly in a matter of maybe 10 seconds. So if you were to give me this drone, I'm somebody who's been working with drones now for 3+ years, it would probably take me 20 plus minutes to understand what's wrong with the drone, how can we fix it, reconfigure it, put it back on the ground, and get it flying. But what we're able to do here is solve this problem in a matter of seconds. So in a lab setting, when you have a single drone, that might not sound like a big deal. But if I was to operate 20+ drones, now this becomes a whole day task, which with a single hardware device, we're able to solve in less than a minute. So that's where SkyShadow is now. Where are we trying to take this? Right now, we're looking for industry partners who are willing to share with us their hardware and, more importantly, their data, so that we can understand the extent to which this software and this device can solve their problems and continue to build out more fault detection and optimization services. Something I didn't emphasize was that this technology not only can fix immediate faults, but we can also use it to optimize flight during flight. So we can increase battery life, we can improve flight parameters depending on mission requirements, on top of the fault detection, which you saw on the previous slide. By early 2027, we would like to have custom small form factor hardware. So right now we're developing this on commercial off-the-shelf parts. The last demo, we're running a Jetson Nano. We're moving over to some Arduino microprocessors to reduce the size, but by developing custom PDB boards and custom hardware, we can really create a nicer small form factor object that is easy to install on any drone and plug in. And then by late 2027, we would like to have this integrated on at least 2 industry partners' drone fleets to see some larger scale implementation. So what are our asks? Compared to other companies that have presented, we're pretty nascent. So we're not asking for much money, just 25,000 in pre-seed capital, so we can continue to have meetings, do our market research, and meet with industry players. More importantly, what we're really looking for is industry partners in the drone and unmanned vehicle space that are willing to share with us their hardware, their problems, and more importantly, their data, so that we can understand what faults during implementation look like, how we can build out better, more robust systems, and really tailor it to their needs. So I think that concludes my talk. Thank you, everybody, for your time and attention.
Thanks, Cameron. I guess drone mechanics is as complex. Richard.
Yes. Hi, Cameron. This is Richard. I'm with a company called Silicon Catalyst. We're a accelerator incubator. for early stage companies in the semiconductor industry. And one of the companies that I'm working with in the incubator is looking at drone swarm communications, semi-autonomous drone swarm communications. As you mentioned, it's going to be completely unmanageable, especially if you look at it on the defense side. And so, you know what's going on with the embargo against DJI drones for the Defense Department versus, I'm just curious, there's lots here to potentially collaborate with one of these companies in the incubator. But I'm wondering if you've reached out to a company like SkyShadow, which is now probably the go-to player for the Defense Department. I'm just wondering, what kind of outreach have you done, and what we might be able to do to help you put you in touch with the right people?
Yeah, great question. So we haven't met with SkyShadow. Last month, I had a talk with a company called Drone, which is actually owned by Axon, which I think is one of SkyShadow's probably largest competitor. They also do a lot of first response drones. And more just a market research meeting. You know, we presented what we were doing, tried to understand if they were working on internal tools that did this. And I think the more positive response we got is, no, we don't have solutions for this yet. They generally, when they give these drones to like law enforcement, you have a training period. They go to a camp for a day or two to learn how to use it. And it's one operator, one drone. But as they're looking for these larger defense contracts that are coming out after Ukraine, they haven't started building out these tools. So we've been getting some interest from their side on stuff like this. I think the biggest help that somebody could provide to us is get us in a room with somebody who's able to actually say, you know, we can send you a drone and we can send you some of our logs, and you can look at what's going on and understand how to create a product that can interact with our drone and provide services for us.
Yeah, I mean, if I understand your value proposition, it's really predictive maintenance as well as just fixing things when they're up in the air or even not getting off the ground. But I think there's some interesting opportunity to extend your value proposition to marry up with the notion of drone swarms, especially as it relates to the Defense Department.
Yeah, absolutely agree. We have a few meetings coming up with companies that are going after the drone swarm kind of field, but so far we're still in the dating process, looking for partners.
Okay. Yes. Yeah, I'd love to follow up. So
yeah, that would be great.
Thank you. Gus Warren.
Yeah. Hey, Cameron. I'm curious. So I know you guys are really early, so you might not have a good answer to this, but in terms of like sort of the long-term business model, very interested to hear how customized you think the software and hardware needs to be for each sort of manufacturer of drones, right? Because that's obviously going to be a really important element for you.
Yeah, no, that's also a really good question. So I have a few other slides from a different deck. I think I took them off of here, but a lot of drones, because the industry is so nascent, a lot of the drones are still built off of very open source code bases. So, and that means the protocols for communicating between drones and an onboard computer use the same language. So there actually is a ton of potential to scale. Ideally, we would prefer this to be a universal kind of plug and play object. Obviously, I can't promise that until we build a few and we understand how it interacts. But I think the longer term plan, and that's why what we really need is not just hardware, but also data, so that we can build a more generalizable fault detection tool. Because the dynamics behind a drone in general are pretty similar, right? So the ability to perform some fault detection, at least on the physical things that can go wrong, is very much within our capabilities. What we need is a wide enough data set that we can train models that can identify the same problems on different bodies. The interacting between our hardware and their hardware itself is actually very, very solvable.
And you're pretty sure you're going to need your own hardware. It can't be an embedded software platform.
There's no reason it couldn't be an embedded software platform. I think right now the idea was to create a hardware device because that seems we're kind of marketing towards that plug and play idea. You know, we give you a little USB size stick, you tape it to your drone or whatever, you plug it in, and it just works. But it could be a software product as well.
Okay, great. Thank you.
Yeah.
Super exciting.